Greetings and welcome to another BM-Block screencast. In this screencast, we're going to continue our journey into the world of YAWL programming and take a look at how YAWL handles arrays and array storage. So let's take a look at that. So over here, I've got a new contract called YAWL Storage Complex. And in this contract, I've got a few arrays here that I've created and assigned using the constructor. So what do we have here? So we've got three different types of arrays. We've got a fixed sized array here of size 3. We've got a dynamic array here of infinite size, and also another dynamic array, but this one is a uint 8. And so what I'm going to show you here is how YAWL handles these array types in terms of getting the values from the array. So what I've done in the constructor here is I set the initial values of these arrays to what you see on the screen here. So let's deploy the contract and see how this works by interacting with the contract right now. Now, if we look at this function here, get value from a fixed sized array, we can see that I'm passing in an index in order to get one of these values out. So presumably if I pass in an index of 0, so get value from fixed sized array, if I call that function there, we get the value 66 out, and if I pass in 1, we get a value of 77 and so on. Now this is working through YAWL by doing the following. We're using the familiar sload function, which takes the storage location and loads that and then passes it on and sets it to the value, which in this case will be returned from the function. And the value that we pass into sload, the slot value, is going to be interesting. It's basically the slot of the fixed sized array. So we get that by calling .slot on the fixed sized array variable. And then we add to that using YAWL, using the add function of YAWL, the index that we want to return the data for, the data we're interested in. So think of it like an offset from the original slot. Now the reason this works in this way is because we're using uint 256. And remember, slots are allocated in YAWL and in Solidity based on 32-bit words. So this is essentially the same as having 3 uint 256 values back to back, which we can grab just through the different slots there. So essentially it is actually storing these 3 uint 256s into the various slots. So uint 256 of the first slot of the array, or the first item of the array, is stored in slot 0, and then the next is in slot 1, and the next is in slot 2. So that's the space that this array takes up. Now the next one is the dynamic array. So how does that work? Well, let's have a look at this function here. First of all, get dynamic array length. Now if you look at this, what it's doing is it calls sload using the slot of the dynamic array. So what will that return? Well, let's have a look. We've got get dynamic array length here, and it returns 3. Now that, by its name, gives it away, returns the length of the array. So let's take a look. We've got 3 elements in this array. Let's just add another element, 9999, and let's redeploy the contract so that we get that change and call the function again. Now you can see it returns 4. So why is that? Why is this returning the length? Well, the way that Solidity works with dynamic arrays is the slot in which its position is going to store the length of the array. So where is the data going to be stored? Well, what Solidity does is as follows, and we can see this in this function here. I can explain it right here. So what Solidity does, and we look at this line here, it takes the Ketchak 256 of the slot where the location of the array is and uses that as its starting point for the data of the array. So the reason that Solidity does this is to avoid any collisions with data that might follow it. So for example, if this, you see this here is a dynamic array. So if I started to add a few values to this array, and if Solidity didn't offset the beginning of the data storage like it does by taking the Ketchak 256 of its slot index, then it would clash with data that follows it immediately. So I might add data like 909, and what would happen is the data 9 would be here if it didn't, if it behaved in a similar way to the fixed array. And then the data 909 would basically completely obliterate this value here. So that's not good. So again, this is how it works. It's taking the slot and it's performing a catch at 256, which gives us essentially the start slot of the data. This is a huge number in the future of the storage slot space of the contract that you're working with. And it basically guarantees that there won't be any collisions of data in this array. So this function here basically takes or stores the array slot that we can, so that we can use it later in this line to get the catch up 256 of that array slot. That gives us the data start slot, and that's where we can load the value from sload. So let's take a look at this. If we pass in to this function an index of 0, then we get the value 9. Let's take a look. 9. If we pass 1, we should get the next value, which is 909, 2, 90909, and so on, right? So that's how the dynamic array works. And finally, we've got the small array, which is essentially is another dynamic array, but this time it's a uint8. And so because it's of a type uint8, it's smaller than the 32 byte word that YAWL works with. So therefore, YAWL is able to pack these values tightly into a single word. In fact, you can fit in 32 of these values, because each one of these values is 1 byte. So we can basically pack 32 of these values. So if I was to add an array of values of the 32 values here in this array, this would all be in the same slot. So let's take a look at that. So we can come down to this function here. I've got this other function called get small array value. It also takes an index, and it works very similarly to this value, this function up here, except I'm returning a bytes 32, so you can see what's going on under the hood and how the data is being stored. So as before, we get the slot, and then we get the data start slot from the slot that the small array starts at, and then we are able to get the value at that index. And we'll just pass in index 0 because that's what we're interested in here at this point. So we'll expand this out, and we will run the function by passing in 0. And as you can see, it returns this 32 byte word, which if we just paste this next to the small array here, you can see that right on the right side here, we've got the values of the array tightly packed in there. So you've got the 8, you got the 88, which is 58 in hex, and then you've got FF, which is 255 in hex. So that was a quick video on how YAWL handles arrays and how you can access elements in an array using YAWL.